this video, I'm going to show you the operation and operational management of one kind of important hauling and excavating equipment, that is scrapers. And there are many types of scraper that you see here. Normally, we use scrapers to excavate, load, haul, and dump the material in a medium to a long haul distance. And there are many times, as you can see, elevating, two axles, single engine overhaul, as you can see, and then three axles, push pull. So basically, there are two scrapers help together for the loading, and the tandem. So there are many other type of scraper, and the application, it will be different for different time. As you can see here, in terms of the two dimension that we are looking at, the first one is the one-way haul distance, how long the haul distance should be, and what is the total resistance. That when we say total resistance is the combination of rolling resistance and grade resistance, something we learned in lesson 3. And the percent is mean the effective rate, 10%, etc. So if it higher effective total resistance or higher effective rate, then the total slope, it will be more, that we need to more rim pull, more horsepower for the scrapers. From that two dimension, as you can see, if we haul in a short distance, let's say 3,000 feet or less, or about 1,000 meters or less, 1 kilometer or less, and then the total resistance is 10% or less, then you can use elevating. If go to higher total resistance, more than 10%, or even with 5%, but have a long haul, then it's more effective to use all-wheel drive. So by its name, all-wheel drive, in that scrapers, bow, the tractor, and the scraper itself have a drive to improve the track, the load for the scraper. And then you conventional, if you have a lower total resistance with the long overhaul. So that different application zone for different type of scraper that we see in these scenarios. And the dash areas, the pull zone, so basically that used for those type of scrapers. So with that, we to determine the production, and we will do that in the next video and apply to problem 2. But for now, as you can see, in terms of the fixed time, we have three-fifth spot time. So basically for scraper in the position to excavate, and then load time, the time needed to get the material onto the scrappers, and then the maneuver and dump time, and then return to the same position again, so that we have the fixed time. And of course, return and load time, travel time, there are the difference. So fixed time include spot, load, maneuver, and dump time. Travel time including loaded and then return with empty buckets. So that we have, and you will see that in the next video and problem 2. But that for now, you see, for the fixed time, we can be able to find out that in that table here. And then come to the typically we need to use the tractor to have scraper to load the material. And there are 3 methods in here. And before I go to detail on this, I want to show you the video, the YouTube video of the how that work in here. By the way, the other side is lower like this. then the tractor pulls the scraper. And to do that, to improve the efficiency of this one by reduce the time to load the material, and there is three methods we are going to talk here with the support of the push from the tractor. So as you can see here, the tractor, the pusher tractor, and this is the scraper. This is scraper, and this is a tractor, something you see in the video. And there are three methods. The first one is backtrack loading. So what does that mean? Is this is the scraper and this is the tractor supposed to have loading. When it gets the optimal load, then the tractor will return back to push another scraper, and that's why we call it backtrack loading. And when the scraper already fully loaded, they will go to a few areas. And this one, as you can see, because the tractor have to go back here, this tend to be the less efficiency, need more time, maneuver time. However, that is typically to apply it in the real application, because we can go back to the same spot, same excavation area. That is the advantage. That's why they normally use. The second one is chain loading, normally apply for the narrow, long cut areas. So we have two scrapper, for example, the tractor have load here, and when it full load, it will continue to go. Then the tractor don't have to go back, go continue, move forward, load the other scraper, load, and then release, and keep doing the same. And normally apply for the narrow, long cut areas. The last one, it will be shuttle loading. So to reduce the time, it maneuver, turn and turn back, and then turn back again to push. What we have here for the shuttle loading, it when they load the first scraper loaded, go to the dump site or the field site, and then they just turn and then push the other scraper, go to the other directions, and that is reduce the time to load. And when reduce the time, increase the production. However, for this shuttle loading, it have to require the two dumping or two field areas. So basically here cut areas, and then there is a field area here which is lower level, and the other area there, so it will be used. So as you can see, even the backtrack loading is not the most efficient one, but it tend to be used because we can load the excavation in the same spot. And you can see it always ideal to put the scraper with the maximum load that they can specify in the manufacturer manual, but that's not the case. Caterpillar, a famous US company, produce construction equipment, and what they find out is that the optimal load time is not necessarily the time required to upload the maximum payload for the scraper. And why that, we can explain simple in this math. So as you can see the curve here from the origins, and this is the load time, and this is the load in terms of band cubic yard or band cubic meter. And of course, the more you increase the load time, you will put more material on the scraper, and at some point you will get the maximum limit of that scraper volume. You cannot exceed the volume they have. But you don't have to wait until to finish the maximum allowable load on the scraper to get the optimal production for the scraper. What people say, let a little bit less. How less? And this is show you. So after the curve here, and you can see if we have a line tangent to that curve, it basically the tangent is the slope. It measures the rate of loading, the rate of production in that scenarios. So what people do here to determine what should be the optimal load time, by first extend the horizontal axis, as you can see from 0 here to the left, and find out the point 8, that distance from O to A is the cycle time minus load time. cycle time minus load time. So whatever load time here, total cycle time, it including the fixed time, something we talked earlier, spot, maneuver, dump, those are the fixed time, plus the travel time, which is during the load time, and whole return empty. So those are the travel time. So total cycle time, subtract load time, you have that is 0 O to A, which is cycle time minus load time. So what people do is from point A there, draw a line tangent to the curve, and it meet at that load curve, meet at B, and from B make a vertical line, go down to the horizontal axis and meet at C, and the OC it actually that the optimal load time. It may not reach the maximum load capacity of scrapper, but the overall it will get the maximum or optimal production for scrapper. Why is that? When it maximum, you will have the production rate in maximum. And when I said earlier, the production rate is basically that will be the slope of this one. And as you can see here, if it tangent to yes, that will be the maximum slope, maximum angle. If you go to the right or go to the left, it will be less. That's why we get the optimal load time for scrapper. And talk about the pusher cycle time with the tractor to the scrapper. We also have the cycle time here for different loading method, backtrack, chain, or shuttle. Remember, we have 3 type of pusher for the scrapper, as we stated earlier, and the cycle time are not the same. And for this one, I don't apply with the problems. But if you're interested about determine how I determine the number of tractors for the with the given number of scrapper, you can do that in with the books chapter 4, but I will not cover that in our lesson 4 here.